Hello and welcome to Pre-Algebra Lesson 42. In this video, we're going to learn about multiplying decimals. So our lesson objective for today is just to learn how to multiply decimals. So before we get started, I just want to mention that multiplying decimals is no more difficult than multiplying whole numbers. If you've already mastered multi-digit multiplication, meaning vertical multiplication, then basically at this point you can already multiply decimals. There's just one additional step that you're going to have to deal with, and that's going to be where you're going to put your decimal point at. So here we go, multiplying decimals. The first thing we want to do, we want to ignore any decimal points and multiply the resulting numbers. So essentially what I'm saying here is that you're going to pretend like your numbers are whole numbers. So if I had something like 5.5 times 3.7, I would start out by pretending I had 55 times 37. All right, I would find the answer for that. Now, in the next step, I want to move the decimal point in the answer. And when I say the answer, I mean the answer to the multiplication I just got where I was using whole numbers. So I want to move this to the left by the number of decimal places between all factors. Okay, so between all factors. So let's jump in and look at an example. So we're going to begin today with 5.15 times 0.32. So I'm going to start out, I'm going to ignore any decimal points that I have. And so this number here will be 515. Just going to treat it like it's a whole number. And this number here will be 32. And I just find this product first, and then I'll figure out where to put the decimal point. So 2 times 5 is 10. 0 down, carry the 1. 2 times 1 is 2, plus 1 is 3. 2 times 5 is 10. Okay, I'm going to erase this. And remember, we're moving to the left here because we're starting over here in the tens place now. 3 times 5 is 15. 5 down, carry a 1. 3 times 1 is 3, plus 1 is 4. And then 3 times 5 is 15. And so now we're going to add. Go ahead and bring down this 0. 3 plus 5 is 8. 0 plus 4 is 4. 1 plus 5 is 6. And then bring down that 1. So what I get is 16,480. But that's obviously not my answer because I haven't figured out where to put the decimal point yet. So just go ahead and come up here, drag this up, 16480. And now we're going to figure out where to put the decimal point at. Now what I told you is that we're going to move the decimal point to the left by the number of decimal places we have between all the factors. So if I look at these two factors here, in 5.15, I have 2 decimal places, 2 decimal places. And in 0.32, I also have 2 decimal places. Okay, we're talking about what's after that decimal point, right? Here I have 2, and here I have 2. So if I combine those two, 2 plus 2 is 4. So between all of the factors here, we have 4 decimal places. So that tells me we're going to have to move our decimal point 4 places to the left. Now, when we don't have a visible decimal point, like in a whole number like we have here, we can always write one at the very end of the number, so at the very right part of the number. And now I'm free to move my decimal point 4 places to the left. So I'm going to go 1, 2, 3, 4 places to the left. So my decimal point is going to go right there. And we have an answer that's 1.6480. But remember, I don't need this 0 here. I can erase it because that 0 does not add any value to the number. After your decimal point, or to the right of the decimal point, after your final non-zero digit, you can add as many zeros as you want. So I could put 0, 0, 0, 0, 0. It's still 1.648, right? These zeros do not change the value of the number at all. All right, so again, our final answer here will be 1.648. Okay, for the next one, we have 0.00153 times 2.71. So again, I'm going to ignore the decimal points, and I'm going to pretend like I had 153 times 271. And I just multiply. So 1 times 3 is 3, 1 times 5 is 5, and 1 times 1 is 1. Now I'm going to the tens place, so I need to move to the left in my answer. 7 times 3 is 21. Put a 1 down, carry the 2. 7 times 5 is 35, plus 2 is 37. 7 down, carry the 3. 7 times 1 is 7, plus 3 is 10. And move over one more time. We're going to the hundreds place. 2 times 3 is 6. 2 times 5 is 10. 0 down, carry the 1. 2 times 1 is 2, plus 1 is 3. All right, so let's add now. Get rid of these arrows, bring down the 3. 5 plus 1 is 6. 1 plus 7 is 8, plus 6 is 14. 4 down, carry the 1. 1 plus 0 is 1. And then 1 plus 3 is 4. So we end up with 41,463. But again, that's not our answer, right? We can just drag this up to the top here. And just to get a little room going, I'm just going to erase this. So again, it was 41,463. My next step is to figure out where I'm going to put the decimal point in this number. If I look between the two factors here, I need to count how many decimal places I have. In this number, I have 1, 2, 3, 4, 5 decimal places, right? 5 decimal places. And this number over here, I have 2. 1, 2 decimal places. So between all the factors, or between both factors, I have 5 plus 2, or 7 decimal places. So that tells me I need to move my decimal point 7 places to the left. Let me erase this real quick. And we'll put a visible decimal point to the right of that 3. Remember, if you have a whole number, you can just put it at the end of the whole number. And we're going to move the decimal point 7 places to the left. So 1, 2, 3, 4, 5. And do I stop now? No, I put some zeros in, right? So I put a 0 in here so that I can do 6. And then one more 0 so that I can do 7. And so I put my decimal point there. I can erase all this at this point and say that my answer is 0.0041463. All right, let's take a look at one with a negative involved. So we have negative 3.01 times 1.8. So remember, when we worked with integers, we learned that a negative times a positive is a negative. The rules are the same for all real numbers. So when you come across a negative times a positive, you're always going to get a negative. Doesn't matter if you're multiplying fractions or decimals or whole numbers or integers. Whatever you're doing, negative times positive is negative. Now, once we figure out the sign, remember, we can just work with the absolute value. So I could just pretend like I had positive 3.01 times positive 1.8. And when we multiply decimals, remember, the first step is just to ignore the decimal point and pretend like we had whole numbers. So 301 times 18. So 8 times 1 is 8. 8 times 0 is 0. 8 times 3 is 24. Now we're moving to the left because we're going to the tens place. We're doing 1 times 301. That's 301. So I'm going to write a 1, a 0, and a 3. And now we're going to add. So just bring down this 8. 0 plus 1 is 1. 4 plus 0 is 4. 2 plus 3 is 5. So I get 5,418. And again, this is not my answer. I'll write this up here next to this negative, 5,418. And I can go ahead and erase this now. And let's just figure out where we're going to put our decimal point at. Again, I'm looking for how many decimal places I have between the factors. So here I have 2 decimal places. 2 decimal places. Here I have 1 decimal place. So what that means is that between all the factors, or between both factors here, I have 3 decimal places. So my decimal point is going to go 3 places to the left. So I'm going to put it right there to start. And then I'm going 1, 2, 3 places to the left. So I'm going to end up with negative, okay, don't forget the negative out here, 5.418 as my answer. Okay, let's take a look at one final problem, and then we'll kind of jump into a section where we'll talk about multiplying by 10 or power of 10, something that's going to help you speed up your multiplication. All right, so we have negative 19.06 times 0.0051 times negative 2.02. Now, what we're looking at here is we have a negative times a positive times a negative. Now, we know from working with integers that if we multiply more than 2 numbers and we have an even number of negatives, we're going to get a positive result, right? Each pair of negatives makes a positive. So I'm just going to go ahead and write that the answer is going to be positive And now we can just think about these numbers as if they were all positive, right? We can just think about the absolute values. Now, the next thing we want to do is multiply any of the two numbers together. And so I'm going to start out with 19.06 times 0.0051. So to do that, I'm going to pretend this is 1,906 times 51. So 1 times 1,906 is 1,906. Then I'm moving to the left here, so I move to the left when I put my answer down. 5 times 6 is 30. 0 down, carry the 3. 5 times 0 is 0, plus 3 is 3. 5 times 9 is 45. Put a 5 down, carry the 4. 5 times 1 is 5, plus 4 is 9. So now let's add. Bring down the 6. 0 plus 0 is 0. 9 plus 3 is 12. 2 down, carry the 1. 1 plus 1 is 2, plus 5 is 7. Bring down the 9. So I get 97,206. So let me write that here, 97,206. Now, at this point, you can figure out where the decimal point would be based on these two right here, or you can keep going and multiply this number times this number here as if it was 202. Now, both ways will work. I think it's a little faster if we just figure out where the decimal point is going to be in the end. So let's go ahead and do that. So I'm going to think that I have 97,206 times 202 for right now. Okay, so 97,206 times 202. And once we figure this out, we're going to put our answer here. We're going to go back and figure out where the decimal point should be. So 2 times 6 is 12. Put a 2 down, carry the 1. 2 times 0 is 0, plus 1 is 1. 2 times 2 is 4. 2 times 7 is 14. 4 down, carry the 1. 2 times 9 is 18, plus 1 is 19. Now I know 0 times anything is 0, so that would have started here. I'll just put 1 0 there. Then we're going to the 2. 2's in the hundreds place, so I'm moving over one more time. My answer is going to start there. 2 times 6 is 12. 2 down, carry the 1. 2 times 0 is 0, plus 1 is 1. 2 times 2 is 4. 2 times 7 is 14. Put a 4 down, carry the 1. Then lastly, 2 times 9 is 18, plus 1 is 19. So now we're going to add. Go ahead and bring down the 2. 1 plus 0 is 1. 4 plus 2 is 6. 4 plus 1 is 5. 9 plus 4 is 13. Put a 3 down, carry the 1. 1 plus 1 is 2, plus 4 is 6. Bring down the 9, bring down the 1. So we end up with 19,635,612. So let's erase this, and we're going to write that up top. So now we want to just figure out where our decimal point should be in this answer. So to do that, we count the total number of decimal places between all of the factors. So if I come here, I have 2 decimal places. So 2 decimal places. Here I have 1, 2, 3, 4. So 4 decimal places. And here again I have 2 decimal places. So 2 plus 4 is 6. 6 plus 2 is 8. So that means I need to move my decimal point 8 places to the left. So I'm going to start it right here. And let me kind of make this number a little bit straighter. So again, put the decimal point here. And we're going 8 places to the left. So 1, 2, 3, 4, 5, 6, 7, and finally 8. So that decimal point is going to go out in front. And we have 0.19635612 as our final answer. So for this next section, I want to talk a little bit about multiplying by 10 or a power of 10. And when I say power of 10, let me just explain that I'm talking about an exponent on 10 that's going to be a whole number that's 1 or larger. So for example, you'd have something like 10 to the first power, which is just 10. 10 squared, which is 100. 10 cubed, which is 1,000. 10 to the fourth power, which is 10,000. 10 to the fifth power, so on and so forth. Right? I'm not talking about raising it to 10 to the power of -4, right? I'm only including these values here. So for the trick, essentially what you're going to do is you're going to move your decimal point 1 place to the right for every 0 in the power of 10. So let me give you something to start with that you're already familiar with. Let's say you had the number 5 and you multiply it by 10. Well, we already know that this is 50. But one of the ways you can figure this out is you can put a decimal point behind 5, right? You can do that with a whole number. And I can put a 0 behind that decimal point, perfectly legal. If I'm multiplying by 10, really all I need to do is take that decimal point and move it to the right one place, because there's 1 0 here. So that tells me that the answer is 50. If I took 5.0 and multiplied it by 100, okay, by 100, there's 2 zeros in 100, so 5.0, move this 1, put another 0 in, 2 places to the right, and I'd get 500. I could do the same thing with 1,000 or 10,000, so on and so forth. Now, really 100 is just 10 squared. So I could replace this 100 with 10 squared if I want. And I know that if the exponent is a 2, I'm going to have a 1 followed by 2 zeros, right? So it's 1 followed by 2 zeros. This tells me how many zeros I'll have. So without even converting 10 squared to 100, I know I just take 5.0 and move that decimal point 2 places to the right to get 500. And so if I ran across something like 5.0 times 10 to the 9th power, I know I would do 5 point, and then I would basically just move this 9 places to the right. So let's do that. Go 1, 2, 3, 4, 5, 6, 7, 8, 9. So because this is all the way out there, I'm going to use some commas now. And we'd end up with the number 5 billion. All right, so let's try some basic ones here. We have 0.015 times 10. So I'm going to take this decimal point and move it one place to the right. And so I'd end up with what? I would end up with 0.15, or I could put a 0 out in front. I have 0.15 in that case. What about in the case of 0.015, same number as above, times 10 squared? Well, really all I need to do is move this one place to the right from here because I have one additional 0. Here I have 1 0, here I have 2, right? I can just look at the exponent. So I can take this number, 0.15 basically, move it one place to the right, and I'd have 1.5. Or you can do it from here and just say, okay, I have 2 places to move my decimal. And again, I get 1.5. In this case, I'm moving the decimal 4 places to the right. I'm multiplying by 10 to the 4th power. There's going to be 4 zeros in that power of 10. So what I want to do is go 1, 2, 3, add a 0, and then finally 4. So that's going to give me 150, or 150, right? Because if I kept this 0 out in front, it would add no value to the number. 0150 is the same thing as 150, right? So that's how we would read that number. Here's an example where this would really come in handy. Let's say you get this on a test. Negative 23.2815 times 0.001 times 10 squared. If you do this without using any technique, it might take you a little while. But the first thing I do is I kind of eyeball it and I see that, okay, 10 squared times 0.001, I can just move this 2 places to the right and have 0.1. So essentially this problem just becomes negative 23.2815 times 0.1, or for clarity we can do 0.1. Now I know that negative times positive is negative, so I know the answer is negative. So if I were to pretend these are whole numbers, I would do 232,815 times 1. Well, that's just going to give me 232,815. At that point I just have to figure out where to put my decimal point. And I'd say, okay, well I have 1, 2, 3, 4, 5 decimal places between both factors here. So the decimal point's going to go 1, 2, 3, 4, 5 places to the left, and I'd end up with negative 2.32815. All right, for the final problem, we have 0.012456 times 100 times 1,000. So 100, most of you should know at this point, is 10 squared, right? That's a power of 10, and the exponent is a whole number that's 1 or larger. 1,000 is also a power of 10. It's 10 cubed, right? So same scenario. So we can use our trick here, And you basically can count the number of zeros between both of these. You have 1, 2, 3, 4, 5, because if I was to multiply these two numbers together, let's say I started out by saying, what is 100 times 1,000? Well, using my trick for trailing zeros, I know that I would do 1 times 1, that's 1, and then I would attach 5 trailing zeros, right? So 1, 2, 3, 4, 5. I'd get the number 100,000, or we could write that as 10 to the 5th power. So let me put this over here, 0.012456. And now to do this multiplication, all we need to do is move our decimal point 5 places to the right, right? Because we have 1, 2, 3, 4, 5 zeros in this power of 10. So let me copy this number. We're going 1, 2, 3, 4, 5 places to the right. And I can delete this 0 and this 0. I don't need them anymore. They're not going to add value to the number. And so we would have 1,245.6.